Greetings, this is Anthony Dick, and this is a walkthrough of AP Statistics 2018 number 1. The manager of the grocery store selected a random sample of 11 customers to investigate the relationship between the number of customers in a checkout line and the time to finish checkout. As soon as the selected customers entered the end of the checkout line, data were collected on the number of customers in the line were in front of the selected customer and the time in seconds until the selected customer is finished with the checkout. The data are shown in the following scatter plot with the corresponding least squares regression line and computer output. Okay, so customers in line, time in seconds it took them to complete the checkout. Here's all my computer data. So let me just run through what these are. Customers in line, that's going to be my Y. That's going to be my, constant, and the customers in line. I'm sorry. I'm not thinking yet this morning. So that's going to be my y-intercept. The first number is always y-intercept. It's always labeled as the constant. This is going to be my slope. There's my r square value. So I could find the r value by taking the square root of that. And because the slope is positive, I know it's going to be a positive number. S is the square root of the residuals. We'll never use that. This is the standard error of each of these statistics. This is my t-value when I take a t-test. This is my p-value if I run a significance test against these values compared to 0. Okay, so A, and that's a lot more than I need to know, but A, identify and interpret in context the estimate of the intercept for the least squares regression line. So I'm just gonna pull off to the side here. A, the intercept for the least squares regression line. Well, the intercept for the least squares regression line is right there. So it's 72.95. Now, that's the y-intercept. So in context here, that's the time it takes, or think about this as an ordered pair. This represents the point 0, 72.95. Okay, so 0 customers in line, 72.95 seconds to check out. So this is the time it takes to check out without anybody in front of you. So this is like coming to the empty line in a checkout line. Okay, part B, identify and interpret in context the coefficient of determination r squared, right there. So part B, and this is one of these phrases that I say you need to memorize. R squared is 0.7333, or you could just leave it as 73.33%. That's fine. Just make sure you include the percent. What this tells us is that 73.33% of the variation in time to check out is explained by the regression on this, customers in line. Customers in line. Or explained by the relationship. The big idea is that 73% of this variable, of the variability in this, is explained by that variable. Okay. One of the data points is considered to be an outlier. Circle the point on the scatter plot, and believe it or not, grading that was worth half the points for this part C. Circle the point, so there it is, and explain why it's considered an outlier. So that's an outlier. Why? Because the pattern's right here. Oops, by the way, I did see people do that, and so if I actually did that, I'd say, there's my outlier. Okay? Why is it an outlier? the point at about, what's that, about 3 and maybe 75 is outside the pattern created by the other points in the scatter plot. Okay? Outliers are outliers in regression because they are outside the pattern created by the points. That's it, guys. This was a real quick, easy problem. It's a number 1 problem, which meant this is kind of warm up your brain. That's it.